Greetings everybody, welcome back to a Coder Journey episode number 7 of the Clean Architecture playlist or course where we are implementing and learning the concepts of clean architecture. So this is the note that I've got for episode number 7 and I've got Visual Studio here as well. I'm on this branch, episode number 7. We're going to talk about the topic of this video, and of course we're going to see the implementations inside of the project. So the topic that I have decided to talk about in this video is primitive abscission. I'm going to tell you what primitive abscission means, what problems it might cause inside of your projects, and how to eradicate the problems associated with this primitive abscission concept. First, let's talk a little bit about primitive abscission. Let's, get familiar with the concept. And right now, what we've got inside of our, project suffers from the problems caused by primitive abscission. I'm going to zoom in even more. So primitive abscission is a common anti-pattern in software design, especially in domain modeling. And in this episode, we're going to explore what it is, why it is harmful, and how to evolve our models using value objects and guard clauses, sometimes even entities, to make them more expressive, robust, and intention revealing. So I told you before, the fact that you can evolve your model as you continue working on the project is a very normal thing. It's very usual to start small and little by little, evolve your model, which is what is happening right now for us as well. So we started as small, and little by little, we are, evolving our model. We are adding more layers. We are, kind of covering more requirements, and this removing primitive abscission is one of the other requirements that we're going to talk about, we're going to tackle in this episode number 7. So what is primitive abscission? Primitive abscission refers to the overuse of primitive types. So we've got these primitive types in .NET like string, integer, datetime, and so on. So primitive abscission means you prefer to use these instead of more meaningful, expressive, encapsulated types. Let me give you an example. Right now, this is what we've got. Inside of our domain, we've got this entity called employee, and for example, we've got this first name of type string and email of type string. So at first glance, you might think to yourself that this is fine. So first name, of course, it's a string, and email, as long as it is a sequence of characters, it could be considered a string. But the truth is that, this primitive type string does not provide enough, let's say, functionality, enough features for this to be suitable for the first name concept of an employee, and we will see why, or the email concept of an employee, right? So a string is very general, it's very generic. We want to have something more specific. We want to kind of enrich a type with more features, sometimes with more limitations, for it to be suitable for an email or for the first name. For example, suppose we want to limit the number of characters a user or an employee can choose for their names. So of course, if we go with string in the constructor of the employee entity, we have to check the number of characters that the user, has kind of chosen for their first name. So because we do not want to repeat, for example, this checking of the number of characters, it is better to encapsulate this feature, this limitation on the number of characters on a specific type and not choose a string, which is a very, as I said, general, generic data type. So first, let's talk about this based on our notes. String is used for names, right? Emails, phone numbers, etc. But a string doesn't express any domain rules. Domain rules. Do you remember I talked about the number of characters? You can assign an empty string, for example, null, something invalid, like not an email, to an email property. So as long as it is a string, it is fine, right? But of course, it doesn't work that way for our domain model. We need to have a specific type for this email address, for example, so that we can put in like more features, more limitations, so that we can convey more specific domain rules. This leads to poor encapsulation and, of course, violations of invariants all over the place. Invariants are the rules that you need to always have in place throughout your domain model. So suppose, as a rule, your employee cannot have a name that is, I don't know, longer than 20 characters. So if that is an invariant for you inside of your domain model, you need to make sure that that invariant, that piece of, requirement always holds true. So you need to find an approach. You need to have a consistent, approach to kind of enforce and implement these invariants. Value objects. To fix primitive abscission, we wrap primitive types in a small, immutable types that enforce domain rules in one place. Immutable, right? They can't be changed. Small, they're lightweight. Like, for example, string, but they're richer than a string. They have additional features. Let's introduce a simple text value object. So take a look at this text. I'm going to take you to Visual Studio. Why not, taking a look at this here. So as you can see here, I've got this record. It is of type record, right? Because I want it to be small and lightweight. It is called a text. Then I've got this value property. It is immutable. I can't set its value from outside of this, type. But I mean, if I want to set the value for this property, I need to go through the constructor, right? And inside the constructor, as you can see here, I've got some guard clauses to, for example, check my invariants, right? For example, the value that is going to sit inside this property cannot be null or white space. It needs to be within a certain range, right? 1 to 10, 1 to 100 characters. And if these guard clauses pass, then I'm going to set the incoming value to that property. Now, that is a value object which wraps a simple string type. And it has some business rules, some domain rules inside of it, inside of the constructor. And it makes it more suitable to be used for example, the first name of an employee. And then to make it simpler, right, to make it more convenient for my entity, for my employee entity to work with this, I'm going to, for example, create these operators as well. These two operators, if you are familiar with object-oriented programming, simply convert a string value. As you can see here, I've got these properties, right? These operators. So basically, these two, convert a string to a text and vice versa. A text into a string. So if, for example, I want to set the name of an employee, which is going to be of type text, I don't need to create a text object and then set the value, but rather I can directly pass in a string, and these operators can do that implicitly for me. So one of these operators is the implicit type, which is used when you want to convert a text, right? I'm sorry, when you want to convert like a text, yeah, into a string, and the other one is explicit when you want to convert a string into a text. So whenever I pass a string here, it's going to return a new text for me, and it's going to pass that string value to the constructor. And whenever I pass like a text and I want to get the string, the value inside of the property is returned. So as you can see, this is a simple value object. It is immutable. It means that after you create an object of type text, you cannot reset the value inside of the property. And of course, it is richer. It has two sets of domain rules in the constructor. It is of course more specific than the simple string type. Back to the notes. So what's happening here? As I told you, the constructor enforces all invariants about valid input type. It is immutable, right? With value-based equality. The implicit and explicit operators make it easier to use with legacy APIs or UI binding. Now the thing that we are going to do is to convert the employee data type, right? And then we're gonna kind of convert the two properties to use the text type rather than the string type. And then we can add other properties as well. If I take you to the employee type, take a look here. So previously, if I go to episode number 6, right? Previously, we've got this full name called of type string. But right now, what is happening is that not only we have kind of separated these two properties into first name and full name, but also we have decided to go with that text value object, right? And then in the constructor of this employee, as you can see here, we are receiving two text objects for first name and last name. And of course, we can also put some guard clauses here. For example, we can check that they're not null, the references are not null, even though these guard clauses exist inside of the text type as well. You can decide to do some guard checking here as well, and then you set these to the properties that you've got. So kind of what has happened here is that we have moved away from the string type, which is a very general purpose, generic, type, towards a more robust, expressive, meaningful, and a richer type called text. And of course, we can reuse this text throughout the domain entity, the domain model. In the future episodes, I'm going to refine this text value object in order to be able to kind of reuse it throughout the domain model. So now each domain concept, email, phone number, salary, can enforce its own business rules, improving maintainability and readability. In the future episodes, we're going to implement phone number, we're going to implement, salary, and so on. Benefits of value object. Let's have a summary. So, clearer intent. So, a text or email address tells reader what this string actually represents. So, it's not just a string simple object, right? It is more expressive. The name even, right? Text or email address, it conveys meaning. It is intention revealing. Encapsulation of rules. Of course, all validation lives inside the value object constructor using guard clauses. Reusability, as I told you, when you develop this, you can reuse it across your domain. Testability, of course, it is easier to test in isolation. You can write some unit tests to test the logic inside of this type, text, right? Text type. And no invalid state, because we kind of construct this a new type, a new object of type text, only if the guard clauses that we have placed inside of the constructor pass. So now you can do what? You can, start small. As I told you, you can wrap only the most important or, the most valuable rules that you've got inside of your domain, and you can move away from, primitive types and move gradually towards more, let's say, meaningful, richer value objects. And this is something that is, part of the evolution that you can have when you are modeling your domain. Primitive abstraction leads to fragile, unreadable domain models. We combat this by introducing value objects. Value objects enforce invariance and intent, right? Improving domain expressiveness. We used text to demonstrate this pattern and updated the employee entity accordingly. Now we can take the same approach and continue, evolving the domain model by, for example, creating another value object for a property called email address, another one for a property called address. It all depends on your domain model, on the requirements. And I'm going to show you in the future episodes how you can, take this idea of introducing specific value objects to remove the problems of primitive abstraction and move towards more meaningful, types. We're going to, continue working on our model in the next episodes as well. Thank you so much, guys. This is the end of this episode. If you enjoyed it, give it a thumbs up and stay tuned for the next one. Till later, bye-bye.